Hello, diggers. My name is Joseph Pavian.
I'm Jackson Klein.
And I'm Kevin Zaponta.
Today we're going to be learning about underwater welding.
So what is underwater welding?
Why do we do it?
And how is it done?
Let's dive right in.
Whoa, whoa, whoa! Hold your seahorses, partner. Let's learn about normal welding first. Welding is any process that heats up metal past its melting point to bond or fuse two surfaces together. Underwater welding at its core is as simple as it sounds. Welding underwater. This is so that things can be assembled and fixed without removing them from the water. An underwater welder must be skilled in both diving and welding. You may be thinking that water and electricity don't mix. You're right. We will be discussing how this is possible, assess the risks, hazards, and costs of this process.
To start, we must distinguish the two types of underwater welding, wet and dry. Let's start with wet.
Wet welding is probably what comes to your mind when you think of underwater welding. The welder literally dives underwater and welds while submerged. This is done using an arc welder, a machine that uses very high direct current or DC current, usually in the range of 300 to 400 amps, to create an arc of plasma between the cathode and the welding surface.
A cathode is a metal rod that is negatively charged that the welder holds near the welding surface to create the arc. There are only a few differences between a normal arc welder and one used in wet welding. First, a welder used in wet welding has extra insulation to ensure there is no current leakage into the surrounding water. This is to protect the welder from getting electrocuted. Second, the cathode used underwater have a waterproof coating to protect the flux.
Cathodes have a special coating called flux. As the cathode is used up, the flux burns off through a chemical reaction which creates bubbles made up of hydrogen and carbon dioxide. While this gas does protect the weld from the water and oxygen, it can also cause issues.
As the bubbles are created, they immediately start rising up to the surface, reducing the visibility of the welder on his work. These bubbles can also collapse the arc, creating imperfections in the weld. This flux also leaves material on the welded surface called slag. This slag protects the weld as it cools. These things make it hard to ensure the integrity of the welds as it is difficult to detect defects.
Now that we've talked about wet welding, let's dive into dry welding. Dry welding is also just like it sounds, welding in a dry environment. You may ask, how is it possible to be dry while underwater? There are a few different methods that accomplish this that we will discuss. Dry welding means that the welding process is done in air while still being submerged underwater. Think of Sandy's home in SpongeBob.
The different types of dry welding encapsulate the complexities of each individual project. Dry chamber welding is where the chamber only covers the worker's head and shoulders and he enters it from the bottom of the location. Dry spot welding is a technique that is used with balloon-sized see-through habitats, and the welder has to insert the electrode into the habitat, which will form a seal around it. Just like that. And then habitat welding is a method where the welders use room-sized chambers submerged underwater that are pressurized.
Here you see a custom-fitted welding habitat being lowered onto a pipeline to be welded. Depth for dry welding is limited to around 8,200 feet due to such high pressures on the welder at these depths. After ensuring correct installation of the seals on the habitat, the welder dives down and swims up into the now dry area. As the welders work, fresh air is constantly flowing through the habitat. Once the job is completed, the chamber is filled with water and raised. After the enclosure is lifted up, proper inspection is done and the process is complete.
Because the weld area is now dry, the weld process of dry underwater welding is nearly identical to regular welding. Steel is most commonly the welded material. Gas tungsten arc welding is the most commonly used method and results in high integrity welds. Other dry welding methods include shielded metal arc, or stick, flux cord arc, gas metal arc, or plasma arc. Using these processes, divers always work in pairs and usually take turns working 6 to 8 hour long shifts.
According to Divers Academy, dry underwater welding is much more common than wet welding.
Underwater welding is a dangerous job with a life expectancy around 40 years old and a death rate of up to 15%. There are many things that contribute to the danger of underwater welding.
These things include electrocution. This is caused by the high current used and water. To mitigate this, always use DC current and have a ground fault that runs to the Earth's surface.
Drowning. This is the result of a delta P or differential pressure. This is when a difference in water pressure causes water to move from high pressure areas to low pressure areas, which hold the diver down. This force can be as high as 1,000 pounds. If a diver were to be caught in such a pressure differential, there's almost nothing that can be done to save them. This can be caused naturally or from a hole in a ship or dam.
Explosions. These happen when there is a buildup and mixture of hydrogen and oxygen gases. These can be avoided with thorough inspections and void spaces being flushed with an inert gas such as nitrogen.
Hypothermia. Being in the cold water quickly removes heat from the body. If a welder is exposed for too long, this can lead to organ failure. To prevent this, a well-insulated wetsuit and an underwater time limit for the welder should be used.
Underwater welding is also hard on a person's body, as they will experience prolonged exposure to harmful gases and decompression sickness. Decompression sickness is when there is a buildup of nitrogen bubbles in the bloodstream. To mitigate this, the diver should not ascend more than 10 meters per minute.
Dangers even include marine life, like sharks or stingray attacks. Because of all the risks associated with the job and the very high demand on the welder's body, underwater welders often work 1 month on, 3 months off, and receive very good compensation.
Typical applications of welding include various repair jobs, such as repairing a ship's hull that was breached at sea, repairing offshore oil platforms, repairing locks, or repairing piping.
Now let's talk about the pros and cons of dry versus wet welding. Wet welding is generally cheaper as there's not much equipment involved besides the welding machine, the welders, and diving equipment. Dry welding can vary largely in cost depending on the method used. For example, dry spot welding a small area will be cheaper than installation of a new pipe flange using a large habitat, which could involve a whole ship dedicated to the project. Think of it this way. Wet welding is the quick, cheap way to get a repair done, while dry welding is used when pristine weld quality is needed and an essential repair or installation. Well, our time's over. I hope you learned a thing or two.
I hope you had as much fun as we did.
Thank you for watching.
Hasta luego.
I bet.